Problem 6. The Acme Company has begun selling an MP3 player called the FooPod at a price of P equals 200 minus 0.05x, where x is the number of FooPods Acme produces each day. The cost for producing FooPods is C equals 140x plus 9,500. Approximately how many FooPods should Acme produce and sell each day to maximize profit? So we want to maximize profit, so I need a formula for profit, and nicely you are given the formula for profit. So we're going to have profit equals P, which we know was 200 minus 0.05x times x minus the cost, and the cost is for 140x plus 9,500. Okay, from here I'm just going to simplify this out a little bit. I'll have the profit is equal to 200x minus 0.05x squared minus 140x. Notice this will be minus 9,500 because it's minus the whole entire thing. Now I'm ready to take the derivative. So when I take the derivative, I'm going to get 200 minus 0.1x minus 140, and then that's done. I'm now going to combine like terms, and when I do that, I will get 60 minus 0.1x, and if I'm looking for a maximum profit, I do know I want to find the critical number, so I'll set it equal to 0. I'm going to subtract 60 from both sides, and now I'll divide by negative 0.1, and so x will be 600 FooPods. Problem 7. Find the x-coordinates of any, if any, of all relative extrema of the function. Okay, if we want to find relative extrema, I know I first of all need to find a critical number, so I'm going to need to find the derivative of this. So since I see the parentheses, I'm going to make this u squared. So the derivative will be 2u times the derivative of what's inside. The derivative of what's inside is 2x. From here, let's just put our 2 times 2 would be 4. U is, we'll have 4x, and then u will be x squared minus 4. And then from here, to find a critical number, we'll set that equal to 0. I notice that x squared minus 4 is a difference of squares, so I'm going to continue factoring. And then from here, we'll have x would equal 0, negative 2, and 2. So on my f prime chart, we will have negative 2, 0, 2. Please remember this is called an f prime chart, so we test things into f prime. So that's where we're going to test it. So when I plug negative 3 in there, if I plug negative 3 in, I will get a negative number. If I plug negative 1 in, I will get a positive number. If I plug 1 in, I will once again get a negative number. And if I plug 2 in, I will get a positive number. So it's asking me for relative extrema. So first of all, I'm going to say, are there any relative maxes? And there is a relative max at x equals 0. And that is because f prime changes from positive to negative. Our function is going up and then it goes back down. And then there are relative mins actually at 2 points. It's going to be at the point x equals negative 2 and at the point x equals 2. And that is because f prime changes from negative to positive. And the function basically was going down and then it's going back up. Okay, question number 8. Find the interval on which the function in number 7 was increasing or decreasing. Okay, we already had our f prime chart from that one. Negative 2, 0, and 2. Negative, positive, negative, whoop, negative, positive. And so when I'm looking for where's it increasing, it's just going to be where the derivative is positive. So it's increasing, increasing. F will be increasing on the interval from negative 2 to 0, and then again from 2 to infinity. And that is because f prime is positive. Okay, and then f will be decreasing. We'll just look at what intervals where the derivative is negative, and that would be from negative infinity to negative 2, and then again from 0 to 2. And that is because f prime is negative. Please remember, each time I'm going, I'm referring to f prime. All right, next problem, number 9. Find the x-coordinates, if any, of all relative extrema of the function y equals 4 cosine x minus 2x on the interval 0 to 2 pi. Alrighty, so first of all, to get relative extrema, I know I need to get a critical number, so I'm going to take the derivative. The derivative of 4 cosine x would be negative 4 sine x and then the derivative of minus 2x is minus 2. From here, I know I need to get a critical number, so I'll take that and set that equal to 0. I'm going to add 2 to both sides, and then I'll divide by negative 4, so I'll get sine x is equal to negative 1/2. So now I need to think, where on the unit circle would the y value equal negative 1/2? And if I'm using my hand trick at all, I know that the sign, any value, it's going to be something to do with pi over 6. So now what I'm going to do is think about the unit circle here. We've got this unit circle. The sign is the y value, so I know the y values are negative over in this quadrant and over in this quadrant. So then if I'm thinking, what's a pi over 6 value that's just a little bit over pi, that would be 7/6 pi. And then if I'm looking for a y value that's almost to 2 pi, that would be 11/6 pi. So my critical numbers for this problem would be 7/6 pi and 11/6 pi. And so if I go ahead and do my f prime chart from there, we would have 7/6 pi and 11/6 pi. And then to the left of this, I think I'll try 0. So if I plug 0 into the derivative, remember, because it's called an f prime chart. Oops, actually, let's call this a y prime chart because it's not f this time. The sign of 0 would be 0, and 0 minus 2 is a negative number. Okay, between 7/6 and 11/6, I notice we've got 3 halves going on right here. The y value down here would be negative 1, so negative 4 times negative 1 would be 4. 4 minus 2 is a positive value. And then bigger than 11/6 would be 2 pi, which is going to have the same result as 0. So we've now got our chart. We want to find the relative extrema, so I could say that there's a relative min going on at x equals 7/6 pi, and that is because y prime changes from negative to positive. My function is decreasing and then it is increasing, so it would cause a minimum to occur. And then I've got a relative max at x equals 11/6 pi, and that is because my y prime changes from positive to negative. My function is going up and then going back down, which causes there to be a maximum value. All right, problem 10, find all intervals in which the function given is increasing and or decreasing. Again, we want to get to a critical number, so we're going to take the derivative. I do notice that I have a quotient, so I'm going to use the quotient rule. My f prime would be negative 1. My g prime would be 2x plus 3. So now taking the derivative, we'd have f prime times g, so negative 1 times x squared plus 3x minus 10 minus f times g prime. And then all over g squared. So x squared plus 3x minus 10 squared. Okay, simplifying the numerator, we're going to have negative x squared minus 3x plus 10. And then the minus negative x actually will become plus x. And when I distribute that, I'll get plus 2x squared plus 3x. It's all over x squared plus 3x minus 10 quantity squared. Okay, then from here, just cleaning it up one more step. Looks like my 3x's cancel. I'll end up with x squared plus 10 all over x squared plus 3x minus 10 quantity squared. And then I would like to find the critical number, so I'm going to set the numerator equal to 0, and I'll set the denominator equal to 0. So if I set the numerator equal to 0, subtract 10, I'll get x squared equals negative 10. To get rid of the square, I'll take the square root. You can't square root a negative number, so that does not produce a critical number. The next part, if I set the denominator equal to 0, okay, first thing I do is to get rid of the square, I'd square root both sides. So I'm just going to be left with x squared plus 3x minus 10 equals 0. That will factor into x plus 5 times x minus 2. And so my critical values will be negative 5 and 2. So if I come up here and make myself an f prime chart, let's put negative 5 and 2 on it. And since it's called an f prime chart, we're definitely going to go into f prime, which was right here. A couple things that I'm going to notice here before I even start plugging values in. Up top, well, let's plug in negative 6. If I plug in negative 6, I'll get 36 plus 10. I'll get a positive number up there. And down on the bottom, no matter what I put in, when I square it, that number is going to be positive. So I'm going to get a positive over a positive, so that will be positive. Now I'm going to pick 0. If I plug 0 in the top, I'll get 10. And again, anything down in the bottom will give me a positive. So again, my answer will be positive. And if I pick 3, I'll get a positive number up top and again a positive number down below. So I'll again get positive. So you'll notice this function is only increasing, but we do need to separate it because at -5 and 2, the function is actually undefined. So we're just going to say f is increasing from -infinity to -5, again from -5 to 2, and then again from 2 to infinity. And that was because f prime is positive.